Archaeology is the study of the human past civilizations, past cultures, past groups of humans. And so one of the important questions that we need to ask when we're doing archaeological research is when? When in the past were these humans doing these particular activities? When was this city built? When was this animal hunted? And there are two ways in which archaeologists determine the age of an archaeological site or any type of artifacts. We have relative dating and absolute dating. Absolute dating is when we can put an exact number on a site. We can say this village is 300 years old, or this house was built in 5000 BC. The other type of dating is relative dating. And this is when we don't put an exact number on something, but instead we say this site is older than this other site, or this artifact is younger than this other artifact. One of the main ways that archaeologists have done relative dating in the past is through a method called seriation. So this video is going to walk through the steps of doing a seriation and also the theory behind it. So to start out, we need to recall the law of superposition, which is a geological law that really underpins this concept of older than and younger than. So here we have 4 layers of sediment, and you'll remember sediment is just the stuff that makes up the ground that we walk on. And sediment comes in layers in many parts of the world. The law of superposition tells us that the layers on the bottom will be the oldest and the layers on the top will be the youngest. So the oldest layers are the ones down here that are deposited first, and then subsequent layers deposited on top of them. We also make the assumption that when we find artifacts in these layers, that those artifacts have the same age as the layers that they are in. So, for example, in this particular set of layers and these 4 artifacts, artifact B is the oldest because it is in the oldest and lowest depositional layer. Artifact C is the youngest, and then artifacts A and D are somewhere between those 2 ages. So the law of superposition doesn't tell us exactly how old. We can't look at this and say, oh, artifact B is 500 years old and artifact C is 100 years old. We don't have any sort of absolute metrics here, but we can tell what's older and what's younger. So if we're looking at archaeological sites, one way that we could determine what's older and what's younger is if we had continuous layers of sediment stretching very long distances. So if we found an archaeological site here, and another one in a layer above it, we could say, oh, well, archaeological site D is older than archaeological site A. So we can imagine if the world had these continuous layers of sediment all around it, we could track things very easily that way in terms of older than or younger than. However, that's not how the Earth works. We don't have these continuous layers of sediment stretching all over the planet so that we can make these very easy older than or younger than determinations based just on superposition. Instead, we have layers and layers of sediment, layers and layers of rock, but these also get broken up. They're discontinuous. So we can't simply use superposition in order to determine which sites are older than what other sites. So instead, we turn to the concept of seriation. Seriation is a method that involves comparing the frequency of artifact types. So if we have a number of archaeological sites, we can look at how many artifacts of each type exist within each of those sites and then use that to determine which sites are older and which sites are younger. So let's talk a little bit about this idea of comparing frequencies. Let's imagine for this example that we are looking at the relatively recent past, so from 1960 until 2010, projecting a little bit into 2020, and we're going to look at the number of some items that are in use in America during that period of time. Let's also imagine, for the sake of argument, that starting in 1960, America has been going through a zombie invasion. But these are very slow-moving zombies. So as zombies attack towns across America, people abandon those towns. So what we see is an America that's full of these tiny little, these abandoned towns, but they've all been abandoned at different times. Okay, so let's go back to mapping the frequency of artifacts that were in use in America throughout this 60-year span. First, I want to look at We're going to compare VCRs and DVD players because these are two pieces of technology that we're all familiar with. So first, let's chart the frequency of VCRs over this 60-year span. This curve approximates how many VCRs have been in American homes over the last 60 years. What we see is that during these very early years of the 1960s, there's really not any VCRs because I believe the first VCRs were invented around here in 1964. When VCRs are first introduced to the American market, there are not very many of them. And that's because it was a new technology. It's also very expensive. So only a few people were able to afford VCRs. As time goes on, the technology becomes less expensive. So it's cheaper to produce VCRs and making it more affordable for more people. So by the late 1990s, pretty much everyone in the US has a VCR. But then starting in the 2000s, really, we see a decline in the number of VCRs in American homes. And maybe people still have them, sitting in an entertainment center or sitting up in your attic or something. But we're certainly not buying VCRs anymore. And that's because other technology has been introduced, like DVD players. So the first DVD players came out, I believe, around the mid-90s. But it took a little while for them to become popular, but then they became super popular. So they really replaced VCRs as the way of watching movies and watching TV shows. And so we see this peak in DVD players somewhere around maybe 2010, 2012. And then the frequency of DVD players starts to decline. And that's because we have other technologies coming in the 2010s, things like Blu-ray, streaming capabilities. So any piece of technology or any type of item that humans produce typically goes through a period where it's not very popular, it becomes more popular, and then it decreases in popularity. And this is the basic assumption that underlies the concept of seriation. So let's now backtrack to our imagined zombie apocalypse, our very slow-moving zombie apocalypse. Let's say that we find 3 towns that have been abandoned, and we want to find out when those towns were abandoned, or at least relative to each other when those towns were abandoned. So our first town, we excavate and we find a lot of VCRs and a few DVD players, but not so many. Our second town, we find a lot of DVD players, not so many VCRs. In our third town, we find a good number of VCRs, but no DVD players. Now, based simply on the number of VCRs versus the number of DVD players, we can now tell which of these towns was abandoned first or abandoned earliest. So in this case, the town with some VCRs but no DVD players was probably abandoned first. It was abandoned at a time where people had not yet started using DVD players because they weren't invented. The second town to be abandoned is the one with a lot of VCRs and a few DVD players. And then the third town to be abandoned is the one with lots of DVD players and only a few VCRs. So again, we can use the frequency of these two pieces of technology in each of these towns to determine that this town is the oldest. So it's the one that was abandoned first. And then this town over here is the one that was abandoned the most recently. So it's the youngest, we could say. So let's take this to an actual archaeological example, something dealing a bit more in the past. Let's imagine that we are working in an area, we have 9 archaeological sites. And remember, a site is just a place where humans have done things in the past. So here are 9 archaeological sites spread over a long distance. This is probably an area of about 250 miles or so. These sites are not connected to each other by continuous strata, so we can't simply use superposition to determine which site is oldest and which site is youngest, and where the rest fall out in between. As we go through excavating all of these 9 sites, we find several types of artifacts. We find hand axes, which are a type of stone tool. We find ceramic bowls, and we find baskets. Now, some sites have all 3. And some sites have only 2 of the artifact types. For our purposes, we're also going to assume that hand axes are the oldest type of technology. Okay, they are the sort of VCRs in this scenario. And then ceramic bowls are the next oldest type of technology, and baskets are the youngest type of technology. Now, simply using the numbers of artifacts found at each of these sites, we can determine which site is the oldest and which site is the youngest. So the first step in doing a seriation is we need to translate these numbers into a graphical representation of frequency at each site. So for site A, we have 5 hand axes, 4 ceramic bowls, and no baskets. What you can see down here is that I have drawn a bar that is 5 centimeters long. That represents the 5 hand axes. I've also drawn a bar that is 4 centimeters long to represent the 4 ceramic bowls. And then I've made a dash here to represent 0 baskets. For site B, we have 0 hand axes, 8 ceramic bowls, and 5 baskets. So down here, for site B, I have drawn a dash to represent the 0 hand axes. I've drawn an 8 centimeter long bar for the 8 ceramic bowls, and a 5 centimeter long bar for the 5 baskets. We continue that process for each of the sites. So for each site, there will be a straight line representing all of the archaeological artifacts represented at that site. And it's very important that the bars that we draw to represent the number of artifacts maintain a constant standard. So in this case, I was using centimeters. 5 centimeters equals 5 hand axes. 4 centimeters equals 4 ceramic bowls. So once we've drawn out all of these bars, the next step is to cut those sites into strips horizontally. And I know this picture is a little difficult to see, but you're just going to take a pair of scissors and cut this strip of paper so that each site is on its own little slip of paper. It's a very important step in the process. And remember, cut horizontally, not vertically. We want each strip to represent all of the artifacts at that one site. Now I'm going to represent that here graphically, or using my computer rather than the strips of paper, but this is the exact same set of artifact types that we see in the picture here. Okay, same numbers are used in this particular example, and you can see when there are no artifacts, I've just made a blank box and the number 0. Our next step is to rearrange these strips so that each artifact type either increases or decreases gradually in frequency. It's basically going to mimic that shape that we saw with the frequency curves of VCRs and DVD players, where there's a slow but steady increase in the number of VCRs, and then a slow and steady decrease in the number of VCRs, and then a slow and steady increase in the number of DVD players, and a slow and steady decrease in the number of DVD players. So for this example, I'm going to start with the hand axes, because I know that hand axes are the oldest type of artifact of these 3. And just for the sake of simplicity, I'm going to start with site F, where there are the most number of hand axes. So site F, automatically I can tell that site F represents a period in time when the most hand axes were in use. So I'm going to put that, for now, at the bottom of my rearranged set of strips, because hand axes are the oldest, so I'm putting that down there. We know that superposition tells us oldest things are at the bottom, youngest things are at the top. So next I want to look for a site that's going to fit logically into the space above here. So I want to see either an increase or a decrease in the number of hand axes and an increase or decrease in the number of baskets. To me, the next logical site looks like site A. It's got the next greatest number of hand axes. So let's just go ahead and move that over. And here we see a decrease in the number of hand axes and an increase in the number of bowls, and baskets still with 0. My next site looks like it's probably going to be E. So let's move that over. Again, decrease in hand axes, increase in ceramic bowls. The next site, you're probably picking up on this, looks like site H. So we'll move that over. Still no baskets, but that's all right. These are looking like good trends with a gradual decrease and a gradual increase. Next will be site I. And here with I, we have the first appearance of baskets. So now if we look back at the remaining sites, we can see that we have no more hand axes left to go on. We've gotten to a point where site I only has 1 hand axe, so that probably represents the end of people using hand axes. So now we want to shift our attention over to the bowls and the baskets, since we have bowls here and baskets just being introduced. Now, we might take a couple times of shuffling this around, but I'm going to guess that we'll start with site B. Site B looks like a good jumping off point in terms of ceramic bowls and baskets. So we'll fit that into our curve, and here we see now ceramic bowls starting to decrease, and a pretty good jump in the number of baskets, but seems reasonable still. Our next site, site G, so we're decreasing still, the ceramic bowls, still increasing the number of baskets. Site D is next, and here we see a decrease in the number of baskets, but that's all right. It's still a nice smooth transition. And then finally site C. So we can see once we've rearranged these strips that we have a decrease in the number of hand axes, an increase and then a decrease in the number of ceramic bowls, and an increase and decrease in the number of baskets. These are all nice smooth transitions, and that's what we're looking for. And here it is a little bit closer up. What we can tell from here, actually let me advance further, step 4. Next thing we want to do, and this is just those strips rearranged on paper, but rearranged to represent those same decrease, increase, decrease, increase, decrease, gradual curves. We want to make sure that there are no gaps in this sequence. All right, we don't want to see a hole in the middle of one of these frequency curves. If there's a hole, then maybe we need to rearrange things a little bit more. And that's the nice thing about working on paper strips like this. It's very easy to just keep moving them around until these curves are nice and smooth. But this looks pretty good. What I can tell from this, or what the determination that we can make then once we have these nice frequency curves, is we can tell which site is the oldest, and we can tell which site is the youngest. So what do you think? Which site would be the oldest according to this seriation? It's site F. This is still going back to the idea of superposition, that the oldest things are on the bottom, which then means that the youngest things are on the top. So site F is our oldest site, and site C is our youngest site. We also then can tell the relative ages of the sites in between. So we know, for example, that site G is older than site D because it is below it in the seriation curves. So while this still doesn't give us exact ages, we can't say that site D is 500 years old and site E is 700 years old. We get the relative ages by looking at younger and older. Step 5 then in a seriation is to pat yourself on the back because you have just created seriation curves and determined the relative ages of all of these archaeological sites. And this is as complicated as it gets. It's a relatively low-tech method for assessing the age of archaeological sites, but archaeologists have used this both explicitly and more implicitly over the years. For 100 years, this has been one of the go-to strategies for relatively ordering archaeological sites. And archaeologists do it just like this, with strips of paper and artifact types. And sometimes there are a dozen artifact types and hundreds of strips of paper. But this is the essential theory behind doing seriation.